The USDA announced $145 million in funding for 700 loan and grant awards through the Rural Energy for America program, or REAP. The funds can help agricultural producers and rural small business owners make energy efficiency improvements and renewable energy investments to reduce energy costs, generate new income, and strengthen the resiliency of their operations. Successful REAP funding applicants must demonstrate the proposed project has technical merit, which is another way of saying fundamental energy concepts must be incorporated into the system design to ensure a viable project. Tony Jimenez, senior researcher for the National Renewable Energy Laboratory, says it's important to understand basic energy concepts such as the difference between energy and power.
They're related but different and tend to be used interchangeably. Even people in the industry are sloppy in their terminology. Energy is a quantity akin to distance or the amount of water in a bathtub. Think of it as an amount of something. Typical units of energy are kilowatt hours or BTUs. Power is a rate. It's akin to velocity or the flow rate through a faucet. Power is the rate at which energy is being created, moved, or used. Typical units include kilowatts and BTUs per hour. Going back to the bathtub analogy, energy would be the amount of water in the bathtub, and power would be the flow rate of water through the faucet. Energy equals power multiplied by time. So that's how they're related. Energy equipment is typically rated in terms of peak power because that's the threshold beyond which the item may be damaged. The peak power rating says nothing about how much power the device will actually produce, transport, or consume, and it really depends on how the item is used and the situation.
It's important to understand how to estimate power and energy production for an envisioned system.
When sizing your behind-the-meter system, compare the system's estimated annual energy production with your anticipated annual consumption. In general, the system's annual energy consumption should not greatly exceed the annual energy consumption of the facility it serves without a good reason. This is less a technical issue than economics. Oversized systems tend to have poor economic performance than systems that are appropriately sized, and most installers will help you size your system appropriately. Or other items to understand are the interconnection requirements and compensation for electricity sent to the grid. Interconnection and net metering are two different things, often kind of used interchangeably. Interconnection is, can you attach your thing to the grid? Typically, in most jurisdictions, there's a process for determining that. Net metering is a way you get compensated for energy you send to the grid. Just because you don't have net metering doesn't mean you can't interconnect. It simply means that energy from your system sent to the grid has less financial benefit to you than the same energy consumed on site. Additional items to note are the applicable regulatory thresholds. For example, if the net metering applies to systems up to, say, 10 kilowatts, then from a financial performance perspective, you probably don't want to go with an 11 kilowatt system because then you won't be eligible for net metering. Similarly, if the easiest interconnection process applies to facilities up to 25 kilowatts, is it really worth it to have that 26 kilowatt system and do the extra paperwork and pay the higher fees? Be mindful of thresholds and don't exceed them by a small amount without a good reason.
He talks about other aspects of the application that might be helpful.
I think if applicants discuss their load, their annual consumption, and they might have to go seasonal, but at least they should provide annual figures, annual production. They'll help the reviewer a lot and give them a warm fuzzy that the applicant has appropriately sized their system and knows what they're doing.
Understanding basic energy concepts will make it easier for USDA REAP applicants to design viable systems and demonstrate the technical merit of the projects they're proposing. Agricultural producers and rural small business owners who want to learn more fundamental concepts can visit the National Renewable Energy Laboratory's Energy Basics. Go to nrel.gov to learn more. Anyone interested in applying for USDA's REAP funding is encouraged to contact their local USDA state energy coordinators for more information. Interested applicants can also visit rd.usda.gov. Enter Rural Energy for America in the search box. Remaining application windows in 2024 end on June 30th and September 30th. Reporting for the National Renewable Energy Laboratory, I'm Chad Smith.